To understand few concepts related to atoms, let's begin with two simple elements, hydrogen and helium. Apart from the difference in the number of electrons and their structure, can you tell me an other difference between these two? Yes, the most important difference lies in the fact the hydrogen is capable of reacting with several other elements, while helium never really does. Helium is the quite unreactive element, does not participate in the reactions. But have you ever wondered why? What makes helium and many other elements also like neon, argon not participate in chemical reactions? And an other question we would have is what makes other elements react spontaneously with each other? The answer is valency. Yes, one of the most important factors for reactions is the concept of valency. But before that, let's have a look at an important concept called electronic configuration. Now, what could this be? As the name suggests, electronic refers to electrons, and the term configuration literally means arrangement or layout. That means the electronic configuration of an atom is the arrangement of electrons in the shells. As simple as that. There are two facts that we need to recall. First, the innermost shell or the first shell rather has the maximum of 2 electrons that can be accommodated in it. Secondly, from the second shell onwards, whichever is the outermost shell, it can accommodate a maximum of 8 electrons. In simple words, outermost orbital contains 8 electrons at maximum. This state is called the octet state. The term originated from a Greek word octa, which means 8. The octet state considered to be a stable state. Let's understand in a simple way. You love chocolates. Now, if there is a bag of chocolates kept open before you, how many you will grab at once? Needless to say, you will try and take as many as chocolates as your hand can accommodate. That means the maximum number of chocolates is what anybody will wish for. Now, what have chocolates do with electronic configuration and valency? Let's understand the relation. As a point of human tendency, we will try and grab the maximum number of chocolates using our hands. Similarly, the atoms would want to have maximum number of electrons their shell get accommodate. That means if it just one shell, like in the case of hydrogen or helium, then the atoms would want to have 2 electrons in it. That will be the outermost shell of an atom. This will help them to achieve a stable state. Similarly, for all the other atoms having more than one shell, it's obvious that they wish to have 8 electrons in their outermost shell. And why is this so? That correct. It's because the outermost orbital of any atom can accommodate maximum of 8 electrons in it. That is the reason all the atoms of various elements are in a constant struggle of attaining 8 electrons in the last shell. That is achieving the octet state. However, it is not possible all to have 8 electrons in the outermost shell. Imagine the case of oxygen. It has total of 8 electrons. So can we have just one orbital around the nucleus containing all the 8 electrons? Absolutely not. In fact, according to the rule, we have to fill 2 electrons in the first and the remaining 6 electrons in the second shell, because the capacity of the first shell is to accommodate a maximum of 2 electrons. So can we say that the electronic configuration of oxygen is 2, 6? That's right. But now this indicates that oxygen does not have 8 electrons in the outermost shell. So how will achieve its stable state? What can be done to have 8 electrons in the outermost orbital? Yes, oxygen can borrow or share electrons with atoms of other elements, right? Absolutely. This is how chemical reactions happen. Wait a second. Are we saying a chemical reactions occur because atoms of various elements give or take or share electrons between them? That's correct. And this is how compounds are formed. Absolutely. The giving or accepting or even sharing of electrons between the atoms of elements give rise to formation of chemical bonds. This ultimately gives us a compound. Now you tell me, how will the atom decide how many electrons be given or accepted? How will they understand that electrons need to be shared with other partner? Who decides all this? Well, the answer to all these questions is the concept of valency. Let's understand this important concept in detail in the next video. Thank you. Thanks for watching the video.